These are the second type of problems what you have. Okay, so you do have approximation, but not like the previous one. All right, look at the first one. Find the approximate value of f of 5.001, where f of x is given by this. Yeah. See, the first part what we have is, you have f of x cube minus 7x square plus 15. Right. Now remember, when you're trying to calculate the value, so you can write f of x plus delta x to get the value, correct? Or dy by dx you can call it. All right, now very first thing, this is nothing but y, right? Now dy by dx you can calculate. Dy by dx will be 3x square minus 14x. Yeah. Now once you have this, the next part what we have, f of 5.001. So this you can write it as f of 5 plus 0.001, correct? So in this case, x is going to be 5, delta x is going to be 0.001, right? This much very easily we can calculate, or it's very easily understood also. The next part what you have, we are going to substitute the value and we are going to find out. Now what we mean by the sentence we are going to substitute and we are going to find out? See here, f of 5.001, you can call this as f of x plus this, right? But how do we calculate the delta y value, the change in the value? Delta y is dy by dx into delta x, right? You guys know this. So what is dy by dx? 3x square minus 14x. Put x as 5. So 3 into 25, that's 75, minus 5 into 14 is 70. This into 0.001, which will become 0.005. See, this is the delta y value, right? Now what we need is y plus delta y, because that's going to give us the approximated value, right? So when you have y plus delta y value is it's nothing but x cube minus 7x square plus 15. There also we are going to substitute the value of x as 5, because you need the value of y, isn't it? Let's do that value now. Now f of 5 will be 5 cube minus 7 into 5 square plus 15. So that's 125 minus 7 into 25. 25 into 7 is 175 plus 15, which will give us minus 35. Right? Now, the formula here I'm going to write. So y plus delta y, this is what we need, the approximated value. Y is nothing but minus 35. Correct? And delta y we have calculated 0.005. So we'll take both of them together. That means the value, that is f of 5.001, will be minus 35 plus 0.005. Alright, which will be minus 34.995. This is the answer, or you can say this is going to be the value of f of 5.001. Fair enough? Let's do the second one, which is very similar to this one, but given in terms of words. That's the difference. Let's do the second one. Now let's solve the second one. See, in the second one, find the approximate change in the volume, right? So you have v is equal to x cube. Now what we need is dv by dx, because only the change in the volume is required, right? So calculate dv by dx. This is going to be 3x square. Okay, so what is delta v? Delta v is the change in the volume. So delta v will be dv by dx into delta x. Alright, so delta v value we need. So delta v is equal to 3x square into delta x. Now the point is to calculate the value of delta x. See, delta x they've given increasing by 1%. Correct? Now your original side is x meter and there's going to be change of 1%. So delta x will be equal to x into 1 by 100, or you can say x by 100, isn't it? X by 100. So if you substitute that, delta v is equal to 3x square into x by 100, or delta v is 0.03 x cube. So this is basically the answer. In the sense, this is the approximate change in the volume of the cube. So this is the answer for the second question. Fair? Let's do the third one now. See the third one now. If the radius of the sphere is measured as 7 meter, so what do we have? R is equal to 7 with an error of 0.02. That's delta R 0.02. Find the approximate error in calculating its volume. Again, it's a volume, and that too we are talking about volume of a sphere, and the formula is 4 by 3 pi r cube. So what do we have? V is equal to 4 by 3 pi r cube, right? So dv by dr, because radius is changing, right? So 4 by 3 pi into 3r square. 3 and 3 cancels. So you'll get this as 4 pi r square. What's the value of r? R value is 7. Substitute r as 7. In the sense, you're going to get dv by dr 4, 22 by 7, 7 into 7. 7, 7 cancels. Correct? So you have 22 into 7 is 154. Or let's keep it as it is, because later on anyway you are going to multiply. Correct? Or maybe you can write it as 88 into 7. Alright, if you want, you can write the actual number. So you multiply and you are going to get it. But I would not suggest right now to do it. Fair enough? See, this is dv by dr. Now what do we need? We are trying to calculate the change, or you can say error in calculating the volume. Right? That's delta v is equal to dv by dr into delta r. Right? So you will have 88 into 7 into 2 divided by 100, which is going to give us the answer 12.32 meter cube. So this is the approximate error in the volume. Alright, this is how you solve third one. Let's do the fourth one now. See the fourth one? The radius of the sphere, 9 meter. The error delta R is 0.03 meter. Approximate error in calculating its surface area. See, it's a sphere and the area of the sphere, that is S is equal to 4 pi r square, right? Do ds by dr. This is going to become 8 pi r, right? This will be 8 into pi into 9, or we can call it as 72 pi. This is ds by dr. Now what do we have? Delta S is equal to ds by dr into delta r. Substitute the numbers. So you are going to have 72 pi into 0.03. Correct? 72 into 3. You need to calculate this one, which will be 216. 216 by 100 is 2.16. 2.16 pi. So many meters square. This is going to be the value. This is delta S. So the error in calculating the surface area is going to be this one. See, whatever problems you have done so far, we have approximated the value, we have calculated the error in whatever we have, correct? So these are the type of problems what you have in errors and approximations. Now, in the next video, we are going to see the next application of derivative.